video is going to go over how to find the magnitude and the direction angle of a vector sum. You can practice this in IXL U.9. This video is really just putting together all the different things that we've learned. There's not really anything new per se that we're learning here. We're just compiling the skills that we've been doing together. So let's recall a few things real quick. First of all, the magnitude, which remember the magnitude is the length or the distance that the vector goes. We can find that by taking the square root of a squared plus b squared, where a is our horizontal component of the vector and b is the vertical component of the vector. And then we can find the direction angle with the formula tan theta equals b over a, with b being our vertical component divided by a, our horizontal component. And we can see just that reminder what I'm talking about here. This is what our a and b are referring to. And just remember with that, for the direction angle, if we are in quadrant 2 or 3, we're going to have to add 180 degrees to compensate for the period of tangent. And if we're in quadrant 4, we're going to have to add 360 to compensate for the period of a tangent to get that correct angle, just like we've talked about in class. So that's real quick, how do we find magnitude and direction angle? So then in the problems that we're going to look at, we're going to be initially given the magnitude and the direction angle of a vector. We're going to need to first convert that into component form so we can easily add or subtract them. And then from there, we can once again solve for the magnitude and direction angle of our new vector now. So let's go ahead and look at a few examples of that. Okay, so we're going to go into, we're already here. Very good. So U.9, find the magnitude and direction of a vector sum. The vector x has a magnitude of 9 and a direction angle of 0 degrees. The vector y has a magnitude of 4 and a direction angle of 90 degrees. Find the magnitude and direction angle theta of the sum x plus y. Okay, so this problem is going to be pretty easy for us to solve because they've given us really convenient angles. Okay, so let's look at the first vector. It has a magnitude of 9 and a direction angle of 0 degrees. Well, 0 degrees would just be right along the x-axis. So that means I have a vector here just going to the right, 9, okay? So let's say this point where it stops here is 9. So that is vector x. So that would mean that vector x, its component, is a horizontal change of positive 9 and a vertical change of 0 because we are at 0 degrees, so we have no vertical change. So let's look at the next one. Vector y has a magnitude of 4, distance of 4, and a direction of 90 degrees. So that's going to be going like this. So here we go up to 4, and since we're at 90 degrees, it's right on the y-axis. So vector y is this times 0. There is no horizontal component. It just goes vertically straight up 4 for our vertical component. So if it wants us to find the sum now, when we add these together, our vector x plus y is going to equal 9 plus 0 is 9, and 0 plus 4 is 4. Okay, easy enough. Now I just need to use my formulas to find the magnitude and angle. So I'm going to free up some space here for me to do that. Okay, so let's go ahead and find our magnitude is going to be the square root of 9 squared plus 4 squared. So that's going to equal the square root of 81 plus 16, which is going to equal the square root of 97. And now notice it says round your answer to the nearest thousandth. So when it says that, that's usually an indicator that you're not going to be getting a perfect answer. It's giving you an indication that you're going to be getting an answer that's a decimal and you're just going to round it. We're going to estimate it. So we're going to estimate the square root of 97, so we can put that in our calculator and we can find what that equals. So the square root of 97 is approximately 9.848857 and so on. It says to the nearest thousandth, so that's the 3 decimal places. So I'm going to put 9.84 and then 9, because the digit after the next 8 is another 8, so I'm going to round up. And that's my magnitude. Now I need to find the direction angle. So for this part, we're going to use, freed up some more space here, we're going to use tan theta equals B over A. And something to note really quick, this vector has 2 positive components. Okay, so I'm going horizontally right 9 and vertically up 4. So that means my vector is approximately going to be somewhere in the first quadrant. So I'm not going to need to add anything to my answer here, so that's convenient. So tan theta equals, my B is 4 and my A is 9. Okay, so I am going to do, here we go, I'm going to do the inverse tangent of 4 over 9. So if I get my calculator out and I input the inverse tangent of 4 over 9, I'm again going to get a decimal, and I can just round that to the closest, to the nearest thousandth. I'm just going to double check really quick that I have, that's what I wanted to check. Okay, so I got a small decimal answer when I initially answered it, and I thought, that doesn't seem right. And it's because my calculator was in radians. So always remember to check that you have your calculator set for what you're doing. So right now I'm dealing with degrees, so I want it in degrees. So now I'm going to try inputting that again. So if you ever get an answer that seems like not quite right, then try checking that on your calculator. Okay, so inverse tangent 4 over 9. I got a little over 23 degrees, so if I round it to the nearest thousandths, I'm going to get 23.962 degrees. 23.962 degrees to the nearest thousandth. So just to review what we've done, first we converted our x and y into component form with the vertical and horizontal component. So I could easily add them, and then after adding them, I've calculated the magnitude and direction angle. Perfect. Okay. So as you continue this lesson, you're just going to continue to do that same thing. When you get up to higher levels of IXL, you might suddenly get where you don't have perfect angles like this. These zeros and 90 degrees are really convenient because it's going to make it really easy to convert that to component form. So just a quick note, when you get to some of the more advanced problems, what you might need to do instead, let's say we have, just as an example, let's say you had vector y equals, and you have, I don't know, a magnitude 3, and you had a random angle of like 21 degrees or something, okay? Obviously this, we don't know some easy answer for what this is. So what you're going to do is you're simply going to put that in your calculator and you're going to get a decimal back. And you can do that for both of them if you would like, for whatever angles you have. Convert them to the decimal, add the decimals together. Try not to round until the end, so keep the digits as long as you can until you're done with your calculations, and then round it to the nearest thousandth to put into IXL. If you guys have any questions, you can let me know, and I'm happy to work through them with you.